Welcome to this video on using resources, a GCSE Chemistry revision guide. We will cover natural resources, water treatment, life cycle assessment, materials, science, and industrial chemistry. Understanding how to manage the planet's resources is essential. Natural resources are materials occurring in nature used by humans, from the air we breathe to fossil fuels. Chemists are vital in refining and replacing these resources. They fall into two main categories, renewable and finite. Renewable resources, like timber and solar energy, are naturally replenished and sustainable if managed well. Finite resources, like metal ores and fossil fuels, are limited and cannot be replaced once used. Chemists also develop synthetic alternatives, such as man-made fibers, to reduce dependence on finite supplies. Responsible use of all resources supports sustainable development. Potable water is safe to drink but is a mixture containing dissolved substances, unlike pure water. Access to safe drinking water is a global challenge. Water sources include rivers, lakes, groundwater, reservoirs, and rainwater. In the UK, water is made potable through sedimentation, filtration, and chlorination. Wastewater must be treated before returning to the environment to prevent pollution. The process involves 4 stages. Screening removes large solids. Sedimentation allows sewage sludge to settle. Biological treatment uses aerobic bacteria to break down organic matter. Finally, the treated water is safely released, and the sludge can be used to produce methane gas and fertilizer. Desalination removes salts from seawater to produce potable water, which is important in arid regions. 2 key methods are distillation, where water is boiled and condensed, and reverse osmosis, which forces water through a semi-permeable membrane under high pressure. Both methods require significant energy input, which is a major limitation. A life cycle assessment, or LCA, evaluates a product's environmental impact from raw material extraction to disposal. It considers extraction, manufacturing, product use, and disposal. LCA measures resource use, carbon footprint, pollution, and waste. However, LCAs can be subjective and are sometimes used for greenwashing. The 3 R's, reduce, reuse, recycle, prioritize managing resources sustainably. Reducing use is the most effective strategy. Reusing products saves energy and resources by avoiding reprocessing. Recycling converts waste into new materials. Remember that reducing is the most effective because it prevents the problem entirely. Reusing materials, like refilling glass bottles, is highly efficient as it conserves raw materials and avoids the energy costs of reprocessing. Recycling involves processing waste into new products. Recycling metals, like aluminium, saves immense energy. Recycling glass saves raw materials. Paper recycling reduces deforestation. However, plastics recycling is complex due to the variety of polymers. Recycling is important because it conserves finite resources, like metal ores. It saves energy, with aluminium recycling, for example, using 95% less energy than primary production. Recycling reduces pollution from mining, smelting, and landfills. It also supports sustainability by creating a circular economy, ensuring resources are available for future generations. Corrosion is the gradual destruction of a metal by chemical reactions, such as oxidation. Rusting is the corrosion of iron, an electrochemical process requiring both oxygen and water. Salt water and acid accelerate rusting. Rust is hydrated iron 3, oxide and flakes away, allowing corrosion to continue until the iron is destroyed. Preventing corrosion focuses on excluding oxygen and water from the metal surface. Methods include painting, which provides a physical barrier. Galvanizing uses a zinc coating for physical and sacrificial protection. Tin plating provides a physical barrier, but if broken, the iron corrodes faster. Alloying, such as with stainless steel, forms a protective oxide layer that self-repairs. An alloy is a mixture of a metal with other elements to improve properties like strength or corrosion resistance. Pure metals are soft because their atoms, all the same size, are arranged in layers that can slide easily. In an alloy, different sized atoms distort the metal lattice, making it harder and stronger. Common examples include steel, stainless steel, brass, bronze, gold, and aluminium alloys. Steel alloys vary in carbon content, affecting properties from soft to hard. Copper alloys like brass and bronze are used for conductivity and resistance. Ceramics are hard, brittle, inorganic materials with high melting points. Polymers are large molecules categorized as thermosoftening or thermosetting. Composites combine materials like carbon fiber reinforced polymer to achieve superior properties from both components. The Haber process manufactures ammonia, a vital component of fertilizers. It is essential for global food production. The reaction is reversible and exothermic. Industrial conditions, like a moderate temperature of 450 degrees Celsius and high pressure of 200 atmospheres, are a compromise between reaction rate and yield. An iron catalyst speeds up the reaction, and unreacted gases are recycled to improve overall efficiency. NPK fertilizers contain 3 essential elements for plant growth: nitrogen for leafy growth, phosphorus for root systems and energy transfer, and potassium for enzyme activation and water balance. NPKs are made by mixing compounds, often from the Haber process, or reacting phosphate rock with acids. Excess fertilizer can lead to eutrophication in waterways, causing environmental damage. Let's review common exam questions. Remember that potable water is a mixture, but pure water is a pure substance. Galvanizing uses zinc as a sacrificial metal. The 450 degrees Celsius in the Haber process is a compromise for good yield and fast rate. Recycling is important as metal ores are finite resources, and it saves energy. To maximize marks, learn key definitions precisely. Use specific examples, such as the 95% energy saving from recycling aluminium. When discussing compromise conditions, explain why they are chosen. For evaluate questions, give advantages, disadvantages, and a conclusion. Finally, ensure all chemical formulae and notation are correct. This quick summary covers the 8 major areas of using resources: natural resources, potable water, desalination, life cycle assessment, corrosion, alloys, the Haber process, and NPK fertilizers. Use this as a final checklist before your exam to ensure you are confident with all the key facts. Review this must-know checklist of topics. Remember key phrases that guarantee marks, like distort the lattice and sacrificial protection. Good luck with your exams. Revise consistently, use past papers, and provide clear, specific answers for the highest scores.